All right, folks, for this video, I'm going to do the Routh Hurwitz criterion completely automatically in MATLAB. I have this code in Python as well. I don't think I have this code in MATLAB. There are already on MathWorks, somebody has already written this program before, but I'm going to do it in this YouTube video here, and so hopefully be able to follow along with how this works. The way I want this to work is I want you to be able to put in any array of coefficients. So I'm going to say, I don't want to make this a function, I want to make this a script. So I'm going to say input coefficients of characteristic polynomial here. And then eventually what I want to do is I want to be able to make it so that you can use the symbolic toolbox. But for now, let's just do it simple. So I'm going to say coefficients are 1, 2, 1. And as a check, I'm going to do a check here. I'm going to do roots of coef, and that's going to tell me that it is -1, -1. So this system is stable. Okay. Now, Routh Hurwitz is supposed to tell you sort of the limits of stability, and so this is kind of neither here nor there. But anyway, so what we need to do is we need to create the first row of the Routh table. Okay, so what I'm going to do is I'm going to make, is this table a built-in function? Table is a built-in function. So I'm going to say Routh table is, I'm going to make it an empty bracket for now. And I'm going to do for IDX is 1, 2, length of coef. And what I want to do is I want to grab the first one, and then I want to skip one, and I want to go to the next one. So I'm actually going to get a 2 length of the Routh table. And I'm going to say, let's see, the first row is empty bracket, and then I'm going to say first row is first row, and I'm going to concatenate coef of IDX. And then I'm going to take the Routh table, and I'm going to concatenate the Routh table to the first row, and hopefully I've got 1, 1 there, and I do. Great. Now, I think I need to pad this thing with zeros, and so I'm going to put an if statement here and say if the length of first row is less than or equal to 2, or I'm going to say while, I'm going to take the first row and I'm going to pad it with the 0. And now I should get 1, 1, 0. And I'm going to get rid of this roots check down here so I can actually see what's happening. Okay, great. So there's 1, 1, 0. There's the first row. Okay, and this is always going to happen this way. So now what we need to do is we need to create the second row. So create the second row of the Routh table. So again, second row is going to be an empty set. And then now what we're going to do is we're going to start at 2. We're still going to increment by 2, and we're going to go to the length of coef. And we're basically just going to do the same thing that we did before. So we're going to take second row, comma, coef of IDX. That's the input array. And then I'm going to take, and then I think I'm going to spit out the second row here. So the second row is just a 2. And so what we need to do is we need to say while, I need to figure out the, say while the length of the second row does not equal or is less than the length of the first row, I want to take the second row and pad it with a 0. And then I want to take the Routh table and I want to concatenate it with the second row. And then at that point, I can get rid of this semicolon here, and I think our Routh table is built. Beautiful. So 1, 1, 0, and then 2, 0, 0. Okay, so we probably don't need these zeros over here, but it is what it is. Yeah, honestly, I think maybe if it's less than or equal to 1, we'll pad it with a 0, because I don't actually think you need that 0 there. There we go. Okay. So now we need to make the next rows. So how do we do that? We need a loop to say, like, now create the next rows. Okay, so how many rows do we need to do? Let's see, required rows is equal to, it's going to have to do with the length of the coef, okay? So this is a second order system, and so this is s squared, this is s to the first, and then you need s to the 0. So it's the, I think the required rows is just the length of the coefficients. So then that means the required rows, I'm going to say to compute, is just the length of the coefficient minus 2. And I'm going to say if required rows to compute is less than 0, I'm going to say display trivial solution. And I'm just going to return. So that way this doesn't even do it. So check and see if this is first order or smaller. Okay? All right, so let's see if that, it looks like everything's the same. Did I put a clear and a CLC at the top? So let's put a clear, a CLC, a close all at the top. Okay? All right, so there's the beginning of our route table. So now what we need to do is we need to create these determinants here. And so, and then I need a loop. So I need to say for loop row is equal to 1, 2, the required rows to compute. I'm going to display computing row, and then I guess I'm going to concatenate. What row am I computing? I'm concatenating string of the loop row plus 2. And then end. So then it should say string str doesn't exist. Num to string. I'm coding in Python too much. Okay, so now I'm computing row 3. So let's see. So first I need the divisor. So if you don't know how to do a route table, by the way, in your by hand, learning how to do this in code is going to be absurdly difficult. Okay, so I'm assuming you know how to do a route table. Okay, so first what we need to do is we need to get our divisor, and our divisor is always this guy right here. Okay, so what I want to do is I want to grab the coef of, so I also need to loop through the columns, don't I? Yeah, so I need to also loop through 4. So I need to say 4 column equals 1, 2. So what's the number of columns? So I think the number of columns is going to be the length of coef minus 1. That's what I'm thinking. And so the divide, and then I'm gonna go ahead and just copy this and say computing row 3, and then I'm gonna say computing column, and then 1. So this is just gonna be num to string of column, num to string of column. Okay, and then I'm going to say the divisor. Okay, so now I can grab the divisor. It is going to be the loop row plus 1, not 2. So take the loop, because the loop row, yeah, it's plus 1, because you're basically going to get the... Okay, so then we're going to grab the loop row here, plus 1, and then the column is going to be the column. Okay, so I'm going to just have that spit out. Let's see. Index in position 1 exceeds array bounds. What are the required rows to complete? It says 1. What's column? 1. My bad. I did coef. I was supposed to do route table. Routh table. Booyah. Okay, so then the first column is 2, and then the second column is 0. Okay. Oh, but the divisor is the same for the row. That's right. So my bad. So the divisor is the same. So it's just 1. So it's always going to be 2. Okay. Then we have to do the determinant, right? So the determinant, you have to do, let's see, you have to go up and to the right, right? So Man, how am I going to get this to? This is actually kind of complicated. I didn't prepare for this at all. I kind of like stumbling through things like this and you guys watching so you can kind of see how I think. So I need to grab the two numbers, depending on the column, let me just grab the numbers first. So I need to grab the two numbers that are up directly above those two numbers. So I'm going to say left half determinant is going to be Routh table of the column. So the rows, I need two rows and I need a starting row. So I need to do loop row. Yeah, loop row to loop row plus 1, comma, and then the column. That's it. So I'm going to get 1, 2, and then 1, 0. Okay, that looks right. Okay. So then I need the right half determinant, which is going to be the same rows, except it's going to be column plus 1. Now it's going to throw an error because when you get to column 2, it doesn't exist. So what you need to do is you need to say if column equals the width of the Routh table. So I think I need a variable called like Routh table width. So this is required rows to compute. I need Routh table width is the coefficient minus the length of the coefficient minus 1. Okay. And then so I need to say if column equals the Routh table width, then the right half determinant is just 0, 0. Otherwise, you grab the column plus 1. There we go. So now I've got the left half determinant of 1, 2, and then the right half 1, 0, and then when you're in column 1, it's 1, 0, and then 0, 0. I'm going to pop this guy out, undock, because this is, sorry, I ate some almonds and now I'm coughing. Okay. So now what I want to do is I want to suppress the output and I want to combine the, both determinant. And I want to take left half determinant and right half determinant. And that will give me 1, 2, 1, 0, and then 1, 0, 0, 0. Okay? There we go. So now I can just compute the determinant. So is det a function? What does it do? Determinant is a determinant of a square matrix H, X. That's actually kind of nice. So I'm going to say that the is number. I'm going to say value. The value that I care about is basically the determinant of that matrix that I just created. It's the negative determinant divided by the divisor. And that's like this. And I get a 1 and a 0. And those are the next row of the Routh table. So basically what I do is I just make an empty vector row, and when I come through here, I say row equals row comma value, and I append that row. When I'm done with the loop row, I take the Routh table and I append that row to the Routh table, and then I just spit out the Routh table. And we're done. Well, okay, we're not quite done, right? Now what we do is we need to check for stability. So we need to grab the first row. And I don't like these displays anymore. And so I'm going to get rid of these displays. I'm going to turn those back on if the code doesn't work and I have to do some debug mode, and I want to suppress this output here. So I want to just say grab the first column, and so first column is just going to be Routh table all comma 1, so that's the first column. I do want to spit out the Routh table because I do want to see it. Okay, and then I want to what do I want to do? I want to loop for idx equals 1 to length of first column. And I want to grab the value of the first column, so first column idx, and I want to get the sign. So s is the sign of value, right? And then I want to say, actually, let's start at 2. And so I want to say s is the sign of first column of 1. And I want to say, let's see, if s is not equal to the sign of value, print unstable, and then break. I think that'll work. Is that not the right? And then otherwise, if we're not unstable, so I'm going to say unstable equals 1. It's a true statement. And I'll put unstable here as false. And then down here, I guess I'll say if unstable, if not unstable, then display system is stable. Blast. Did I spell something wrong? Of course I did. Okay, so this system is stable. Okay, so let's grab some bigger functions. So I'm gonna pause and grab the textbook real quick. Okay, so I found this polynomial here, s cubed minus 6s squared minus 7s minus 52. And here's the Routh table that they create. So I'm going to plug in these coefficients, 1, -6, -7, -52, and I'm going to see if I can get this first column here. This is clearly unstable. There's a sign change right here. But let's see if the code can do it. So let's see. I'm going to type in 1, -6, let's see, -7, -52, and hit go. Of course, it threw an error. So let's see. So first of all, let's get this down here, and let's go into debug mode and see what's happening here. So let's get rid of. So let's let it spit out the first row. So it only went to. Okay, but then I said if the length of the first row is less than 1. Oh, okay, that's not right. I feel like, yeah. But see, is this going to work? Is this going to work even if, oh, did I put a print statement somewhere? Yeah, I meant display. Let me have, I need a couple like edge cases. Coef is 1, 2, 1. It looks like it worked, by the way. Is that going to work? Now, now what happened is that the second row, so here's the Routh table width. So I just need to do the Routh table width is the length of the first row, like that. Did that work? No, it still freaked out. Oh, okay, see here, I need to change this to Routh table width. Haha, okay, so there we go. So now the Routh table is working, everything is good, so that edge case works. And then let's try this one here. Okay, that works. So here's the first column, unstable, and then here are the roots of my polynomial. So there's clearly a positive root here. Okay, so it works for this case. I know I only tried 2, but I'm going to say if it worked for those 2, it's going to work for all of them. Let's try and find another example just for kicks. Okay, here's one. S to the 4th, s cubed, 11s squared, 6s 200. So 1, 6, 11, 6, 200. So 1, 6, 11, 6, 200. Was that right? 1, 6, 11, 6, 200. Okay, and I don't even want to know if it's unstable or not. So I got 1, 6, 10, -114, 200. So that's unstable, and the polls say that it's unstable. And the Routh table is 1, 6, 10, -19, 20. 1, 6, 10, -19, 20. They divided by 10 here, and so I think it screwed up their. They like to. So I got where's the Routh table? Yeah. See, I got 6 and 6 here, and then 10 and 200, and then I got -114 here. They thought it was a good idea to divide by 6 and get 1 and 1, and I got 6 and 6, and then I had 10 and 200, but they divided, so they got 1 and 20, and then they got -19. So I think my Routh table is right. So this is working. So this is good. So now the question is that if I do sims k, right, and there's an example in here that I want to test. So by the way, my Routh table does not work if you have a 0. But I could probably add that in later. What I really care about is, can I add in a k here? So I'm going to do 11877k and see if I get this answer here. So let's see, coef 11877k. Does that work? Blast. I do not have the symbolic toolbox, which means I could either do this in Python and then show you how to do it in Python, or I could just stop the video here, and if you had sims k, you can try this code. So I'm going to just push this to GitHub and say, hey, if you have the symbolic toolbox, try this. And I'm going to comment this out. If you don't, you're going to get the same error as me. But at least you have some Routh table code here that will compute a Routh table for you. So if you at least try this edge case, you have a completed Routh table here. So if you do it by hand, you can check your work with this code to see if it works. If a 0 pops up, you won't be able to do it. Maybe I'll do that in a future video. And then, shameless plug, I do have a Routh table functionality in Python that is way better than this. You can do symbolic manipulation. It can handle zeros, and it can do all that jazz. But anyway, I hope you enjoyed this video, and I guess I'll post in the comments if you want to see anything else.